Hello, Keith Rucker here at VintageMachinery.org. Guys, today got a little emergency repair job out at the museum. This past weekend, they were running the steam locomotive and they were going across the dam. They had a load of people on there and it just quit. Wasn't running right. I went over there and looked at it and basically we were not able to get it to move. One of the pistons was at top dead center. The other one should have been in, or was in mid-stroke, but normally it would push on that one and go, but it wasn't. And I kind of felt like we had a problem with the valves, which we've had some problems with this before. About a year ago, we had a yoke that moves the valve back and forth in the slide chest. It actually broke. And kind of suspected the same thing had happened. This was on the other side. I had done this repair about a year ago on one of the valves, on one of the steam engines, but not on the other. When we did it on the other one, I said, you know, next time we get into the steam chest, I'll go ahead and fix this other one and go ahead and replace it. Well, guess what? We haven't been into the steam chest until now, because when we opened it up, sure enough, the yoke that moves that valve back and forth broken, just exactly like the other one did about a year or so ago. This is, to my knowledge, the original yoke that was on this locomotive, over 100 years old, and yeah, they both basically have fatigued and worn to the point where we had issues with them, and both of them, which is not unusual. If one part breaks on the locomotive, there's other ones that are like that. Usually they all kind of fail within pretty short time frame of one another. It's been my experience. Anyway, we got to do this. I actually did a video on this same job probably a year or two ago. I don't remember exactly how long ago it's been. We had the same problem. I'm going to go ahead and videotape this one as well, just because it's what I'm working on in the shop. I know you guys enjoy seeing that. Let me zoom in here, kind of show you this. If you don't remember from the other video, I'll kind of go over how this works and what we're going to do and how this was originally done and how we're going to do it now to get things back up and going. So let me show you what's going on. So on this steam locomotive, you got two steam engines. There's one on each side. Each one of the steam engines has, of course, a piston that's going back and forth, and there is a valve, a slide valve that slides back and forth that basically ports the steam to the piston and the exhaust stroke and so forth like that. What you're seeing right here, this is the actual valve that fits up in there. On the bottom side of this, it's just kind of an open area, and it just slides across some openings. Basically ports the steam to the intake cylinder. This actually is controlling the exhaust side. So basically, when it gets to one place, it opens up a port that goes to exhaust. It covers it up from the other side and lets that side go to the steam to move the piston. This just slides back and forth over the valve ports. And the way it slides back and forth is there is a yoke that fits over this. There is a rod that fits up into the front of this, and this is then connected up to the timing on the engine through the reversing gear. There's a centrix or whatever that just slide this thing back and forth, probably about that far, and it's just porting the steam back and forth. Well, what has happened here, as you can probably tell, yeah, we had catastrophic failure. This thing broke right there where the rod, the valve rod, goes in there and is connected to this. Now, again, as far as I know, this is the original yoke that was on the locomotive, but it's been worked on and modified, and things have been done to it over the years. Now, the first time I ever worked on this was probably about 15, 16, between 15 and 20 years ago. I don't remember exactly, but the valve rod had just basically right down here, you can kind of see where this one here was a chrome plated rod, but you can kind of see where the chrome plating is worn off, and we got some wear in there. That's just where it goes back and forth. There's a packing gland, and sometimes it gets out of alignment. It kind of scrapes on the side of the metal, and it's scraped off. Well, the original rod that was in here, I mean, it had worn so much that it was probably a good 1/4 inch in diameter smaller in that area that goes up in that stuffing box. And of course, every time we put packing in there, it would just rip it out. So I replaced the rods, and this is actually the rod that I replaced it with right here 15, 20 years ago. We used chrome-plated rod just to hold up better, and it did hold up better, but it's still, again, after all these years, it's starting to wear back down a little bit. But anyway, those had been replaced. The rods that were in there were not the original rods. They had been replaced. This one here has been replaced since then. But when this yoke was new, I've actually got blueprints for this right here. That's the blueprints from the Vulcan factory. This was actually all one forged piece of steel. This was all forged valve yoke, forged steel valve yokes. This was all one piece. It was turned on the lathe. The interesting thing is when you look at this one here, it has a center on the back side of this where this whole piece was put into the lathe. It was all one piece and it was turned. Well, at some point in the past, and maybe even multiple times in the past, the valve rods had worn out. At some point in time, they cut them off, they bored out these holes, and the new rods went in, and they were just pinned in place. All these had was just they wasn't even a tapered pin. It was just a spring pin. That's all that held that in place, and it just pulled back and forth. Well, we got a fairly thin profile. Again, this was all originally forged steel. It was all one piece. Fairly thin profile, got the hole through there. That was the weak point. That is where it finally, after 100 and something years, this locomotive was made in 1917, so almost 110 years old, it just finally fatigued and broke. So what we're going to do is we're going to actually make a whole new yoke and a whole new assembly here. So let me show you what we got. When this happened the last time, I had some new yokes made. These were flame cut on a CNC cutter, CNC machine that basically just flame cut this out of some solid steel plate. So instead of having a forged steel, this was just steel plate. And again, this was just rough flame cut. I asked for 2 of them. They actually made me 4 when they did them at the shop that did these for us. And this is what we're going to make the new yokes out of. So this actually fits right down over there. I've come in here and had to do a little grinding on it and cleaning it up or whatever, but that fits down perfectly over the valve, and that's going to let that slide back and forth. We've got the place up here in the front where the new valve rod's going to go in, but because I can't do a one piece and because I don't want to do like they did before where they had that large cross section that is thin, the rod that goes in here is a 1-inch diameter rod. What I'm going to do is I'm going to turn this down to 3/4 of an inch. It's going to be threaded with 3/4 inch fine threads. We will thread that up in there. That will be what holds it in place rather than a pin. It'll actually be threaded, which will be stronger. Won't have to worry about a pin falling into our engine and coming out. It will be removable. We can take these out and replace these rods in the future fairly easily. If we need to, I just make a new one. And that's how we're going to basically go forward. And the smaller, going with a 3/4 inch diameter hole just leaves me more steel up on the top and the bottom, so it's not as weak as this original one here when it was modified. So that's kind of my game plan. That's what we're going to be doing today. And we've got some machining to do to these parts to make it all happen. First off, on this yoke here, when they were flame cutting this, the thicknesses going around here, the original ones are thinner, but they needed enough material there to be able to flame cut that. So these were cut a little bit oversized on the outside. I'm going to put this up on the milling machine. We're going to mill 3 sides of this. The front side is going to stay the same, but we're going to mill the 3 sides so that we have proper clearance for this to go back and forth. One thing I will note, the sides of this, they're not touching anything. They're just in there. They're not on any kind of guides or anything like that. I mean, this could be just a rough surface all the way around. So I am going to mill it to get it to the proper thickness. I'm not going to spend a whole lot of time worrying about getting them perfectly square and parallel and all that because it doesn't matter. It could be just cut out on a bandsaw or whatever. It'd be fine. We just need to have the clearance in there. So I do need to cut these down to size. These need to be about 7/16 inch thick. The back side needs to be about 5/8 inch thick. And right now, I think it's closer to 1 inch thick. That's what they had to do for the flame cut. So we're going to do this over on the horizontal mill, just basically mill those sides out. And that's going to be step 1. Then we'll go drill and tap the front of this for our new valve rod, and then we'll have to machine a new valve rod. I got some more of this chrome plated rod. We'll have to turn this down, thread that in, thread this in for the adjustments on this end, and it'll all be ready to go back into the locomotive. Let's get to work. So I'm just going to do this by clamping this down straight to the table. I've got a big face mill up here that we can just face off the side. This gives me plenty of clamping pressure where this is clamped down nice and tight to the table, and tends to work out real good. It's just a little bit more of a sturdy setup than trying to do it on the vertical mill with this sitting up in a vise. So I'm just going to take a machinist square here, come up to the side. I've kind of got it eyeballed in or whatever here. And again, this is not anything that's super critical. I just want to get it more or less square. I'll go ahead and snug these down now, tighten this up, and then we'll be ready to zip down this face and get that to the correct thickness. And that needs to be 7/16 inch thick. 7/16 is 0.4375, and we're basically an inch thick right now. That's a rough cut, so it's not an exact inch, but we don't need it's just not, again, a critical measurement. It just needs to be somewhere there close. All right, let's fire the machine up and make that first pass. Because my cutter is turning in this direction, basically counterclockwise, I want my cutting force to be pushing down to the table, so we're going to cut on this side on the downstroke. And I'm going to have to get my speed set to the right speed here. Give me a second for that. All right, we got a speed there of 214 RPMs. According to my calculations for a 5-inch cutter on steel, about 250 is optimum. There's kind of a range. So that's in the ballpark where we need to be. I'm just touched off there. And I'm just going to, I think I'll just start with about 100 thousandths on that rough cut. So roughly right there, lock my table down, and let's see how this goes. My feed rate right now is 10 inches per minute, and it's cutting that with no problem whatsoever. About 900. All right, I'm doing 150 thousandths depth of cut this cut, so about 50% more than that last one. Cutting it like butter. Ideally on this, I'd be using coolant here to keep it cool, but I don't have my machine set up with coolant right now, so we'll just get it done without it. That puts me about 3/4 of an inch. I'm just going to do another 150. That seemed to work pretty good. Here we go again. At 600. Another 150 will put me about where I want to be, so we'll do another 150. This should be our final pass. I'm going to let it cut all the way across that cutter here. Just be make sure we got a smooth surface over there. Again, it's not really going to matter for what we're doing, but we'll just make sure we got a nice finish on that side. All right, that side is done, and I mean, it's warm, but it's not super hot, so it's actually better than I thought it'd be. We're gonna go ahead and clamp this down again. I'm gonna do the back side. This back side goes to 5/8 inch thick, so a little bit thicker. My square. All right. Clamp those down and we'll mill that back side down. All right, touched off right there. All right, that's got that one to size. Got someone joining some wood back there in the back wood shop, so you hear some noise. But anyway, we're gonna flip this around, we'll do the other side and get it knocked out. I'll bring you back when we get it done. All right, I've got this piece here all finished up. It's on the milling machine anyway. Got our sides and our back cut to the proper thickness. You can kind of see what we started with the original rough one here. Here's the broken one here. This one doesn't look like the back's thicker, but according to the blueprint it should be, and I'm just making it the blueprint. We got plenty of clearance in there, so that's not a problem on the front end or the back. Won't hurt anything like that. Went ahead and took this to the belt sander, just cleaned up, deburred everything, took a file, cleaned up everything. It fits over the valve just fine. So that's perfect. Now what we need to do is get our hole drilled and tapped here on the front for the rod to go into. So I basically need to find the center. One thing I did do is this original one over here had L stamped on both sides, and that means it goes on the left side. I don't know if you can see it or not, but I took a stamp and stamped this L as well. So let's see what we got here. 10 inch, 220 thousandths, so that'd be 5/110 would be the center. So right there. Let me get something to mark that with. Okay, so that should be roughly the center here. Yep. And then we'll find the center in the other direction. So that's 1.5 inches. So it'll be 3/4 will be half of that. 750 thousandths. So I need to basically drill a hole right there. I get a center punch and punch that, and we'll go get that drilled out. So to drill these out, I mean, guys, honestly, I could have done this on 6 different machines in my shop, but I really just kind of wanted to play with my horizontal boring mill, so I set it up over here on the horizontal boring mill. I could have done this on the horizontal milling machine. I could have done this in my radial drill. I could have done it on the vertical mill. There's lots of ways to do it, but I really just kind of wanted to play around with this machine, so I got this set up. I basically had to set this up on some blocks to kind of get up a little bit higher because my head is just all the way down, but I've got this centered up on that center punch hole. We're going to drill this out. I'm going to put a pilot hole in there, and then 11/16 hole will be for the tap size for the 3/4 16, I think, thread is what we got there. 3/4 inch fine thread, and we'll go ahead and get that done. And I think the last step I'm going to do is I'm going to also just kind of face off this little boss so that it is square with the hole, because that shaft is going to go up against the shoulder, and that, I think I'd rather have a finished cut there rather than just a rough cut. I think it'll just tighten up nicer. So that's kind of the game plan. We're going to do it over here on my 100-plus-year-old Lucas horizontal boring mill. we're ready to tap. I'm gonna put a little anchor lube on here to lube my tap up. I've got a tap follower in the spindle here, which will keep it lined up nice and square to the hole that we just put in here. And we'll just tap that in. Tap handle's hitting a lever down here. Let me back it off just a little bit. We're pretty much through there. And that's good. All right, back that out. Now to mill that, I'm gonna change my cutter out here and put a face mill in my machine. Let's see, I think it's going the right way. There it goes, breaks loose. I'm just using this quick change tool holder here. I'll put my face mill in, tighten it up, and now we'll just come across that face. And I'm going to feed in just a little bit more here. I'll reverse my cutter across there. And that should slowly feed across. Got my feed rate probably set a little bit lower than what it needs to be, but I'm just going to let it roll. That, I think we got our machining done on this yoke. Now I need to make my shaft to go in there to put into it. So I've got the valve rod material in. I've gone ahead and cut this to length, and we're going to go ahead and start machining it. I'm going to start by just facing this backside. I'm going to mark zero that out on the digital readout. I need to turn down this side to screw up into the thing. This is 1 inch diameter stock. It needs to go down to 3/4 inch. It needs to be threaded, what was it, 3/4 16, I think. And I need to turn that down 3/4 inch down to 1 inch, 150 thousandths deep. So I'm just gonna measure in on the digital readout, 1 inch, 150. Right about there. Put me a mark on there. And we'll cut that off. Now this outside is chrome plated, so it's real hard on the outside. I'm going to take a real light cut to start with. Once you get up underneath that, it gets softer. But that chrome plating is hard, so I'm going to start out kind of small there, small cut. Get my diameter and put that in the digital readout. So we're measuring 1 inch, 958, 1958. All right, 958 thousandths. I'm going to 3/4. Again, I'm going to take some light cuts just because I know this material's hard. Cut our shoulder back there too. Make sure we got a nice square shoulder. And one thing I'm going to do right here is, because I'm going to be threading this all the way up to the shoulder, and because I can't get my threads all the way up to the shoulder, I'm actually just going to machine out a little area back there in the back for my threads to kind of come into. Just a little root area back there in the back. And that'll just give me some clearance for those threads and allow that to go up to the shoulder. just come in about that far. All right, that ought to work. I'm going to put a threading tool in here, and that should clear right there. I'm going to turn my speed way down low. Go ahead and kind of chamfer the lead-in edge here. Touch off, feed in a couple of thou, and I'm going to do a scratch pass first, make sure I got my thread set right. Check this with my thread pitch gauge for 16 threads per inch, and yes, we are indeed on 16 threads. All right, we're ready to cut these out. I'm gonna feed in a couple more thou, put some oil on this, wait for a number to come around, and we'll cut this out. All right, that's going up on there. And that's a nice fit. We just take it all the way up on. It's a little tight, but I'm able to get her on there. And that should tighten up right onto that shoulder and be just a little bit shy of being on the inside. Perfect. All right, I'm gonna take this off. We're gonna flip it around. We need to put some threads on the other end as well. All right, so this is the other end of the shaft. I'm gonna start by facing it off. I'm gonna put a center in this end and give me some support while I'm threading it. It's gonna have to stick out a little bit. With this being hard, I know I'm gonna get some flex. So we'll just start by facing this off. Let's take a little center and get the end of that shaft just a little bit. All right, we should be set up here ready to go for 1" 8. So again, I'm just kind of chamfering the front edge there. This is where I want to go to right there. I'll make a scratch pass and check it for size. Sure we're on 8 threads per inch, and we are. Oil on here. Since I'm not going to a shoulder, I did speed up the lathe a little bit. I can not worried about crashing my cutter as bad here. do a scratch pass and then we'll check it for size. I've just got a nut here. And it's still a little bit on the tight side. It's going, but it is just a little bit tight. Just needs about a thou or two more. I think we'll have it. Back down to my 0. I'm just going to give it about 2 thou feet in. Doesn't look like it's taking much, but we'll check it. If we're going to let that roll, that's so just a little bit tight, but I can get it up there by hand, so I think that'll work. And actually, once we get past the bottom, that feels real good. We'll just leave that nut on there because we're going to need it for a jam nut on the actual part. All right, we're done with that. And just like that, I think we're ready to go. We got the yoke, we got the rod going up into the yoke. I'm not going to screw it all the way in because I'm going to have to take it out to put it back together. We got to drop this in and then screw this rod in and then connect the other one. So we'll just leave it like that. But that will push that valve back and forth inside there and port the steam where it needs to go up in the steam chest. I think we're ready to put this thing back together, which I will probably do tomorrow. And probably won't see that on video, but if you want to see that, you can go back and check the previous video where we did one of these. I think I actually showed the actual steam chest, but because we need to get this thing going, I'm just going to go ahead and get it going tomorrow. And once again, I think we're ready to roll. So our yoke fits the valve. This should be a nice replaced valve rod. Won't have any places pulling packing out, which will be a nice big improvement over what was in there before. That's been worn. And hopefully, if all goes well, this will last another 100 years. And the next guy that has to do this job won't be me, I hope. All right, guys, with that, that's going to be a wrap. As always, thanks so much for watching. Please subscribe to the channel if you haven't already. Those thumbs up and comments are always greatly appreciated. Please hit that bell icon up there to get notifications when new videos are posted. As always, a big, huge thank you to those who support the site financially through Patreon, PayPal, and through YouTube memberships, all of which are great ways to help support the channel around here. And with that, I'm going to get out of here. We'll catch you on the next video. Again, as always, thanks for watching.